Good evening. Today we will walk you through our project titled Airbnb Market Analysis, and we're looking at the pricing, prediction, and optimization in New York City. So this project basically integrates the descriptive, predictive, and prescriptive analytics, which helps Airbnb hosts in New York City make smarter pricing decisions. So I have here with me my team members. My name is Baldwin.
My name is Louisa.
My name is William.
Okay, so the introductory part of this project takes into consideration the main problem that Airbnb hosts face, which is very inconsistent. And first of all, we are going to explore the descriptive analytics to understand the market behavior. Also, we are also going to look at the predictive models to estimate prices with machine learning. Then finally, we implement a prescriptive optimization model, which identifies the best pricing strategies. So we now go to the background research. So New York City is one of the Airbnb most complex markets where prices fluctuate based on neighborhood, room type, host behavior, and also tourism patterns. So it is very important for us to find some key findings from the literature. And this is based on the location of the room type, and the room type which heavily drives prices. So we also found out that machine learning models, especially the tree-based methods, tend to perform better due to the non-linear nature of the market. Now, we also look at the problem presentation, and this is the most important part of our presentation because this is what is going to help us to know what exactly we need to address in our prescriptive analysis. So the main problem we address is how hosts can set competitive, data-driven nightly prices. So many hosts underprice or overprice listings due to their lack of market information, or sometimes they use their own intuition in making up prices. So we frame three guiding questions, which which looks at a descriptive question about the structure of the market, and also a prescriptive question about what drives price, and a prescriptive question about how to optimize pricing geographically. Now we also look at the specification and design. So we follow the three step analytical workflow. First is to understand the trends and the segmentation. Second, we look at the predictive analysis. That is, we test the linear regression, decision tree, and the random forest. Now, we also move to the formal model specification. So in this particular slide, we outline the formal structure guiding our prescriptive optimization model. And the objective of our model is to maximize the distance weighted average predicted price for Airbnb listings. So this means that we're not just looking at the prices that we are listed alone, we are also weighing it to how close they are to a chosen geographical anchor. Now the next slide also looks at the data acquisition, where we use the 2024 Airbnb New York City listings dataset from Kaggle. With this data includes pricing variables, property characteristics, host attributes, and complete geographical data.
Okay, so here we have the descriptive results. So looking at the central tendency table, we see that there's an average number of nights as roughly 29 nights, and we also see that the mean nightly price is $187.78. We also see that the median shows that half of its listings, or half of the listings, are priced below $125 per night, and the typical minimum stay night is 30 nights. The dispersion table also shows the standard deviation of about $122. It shows that the prices vary a lot across listings, with a mix of budget options or budget-friendly options and very expensive rentals, pulling the spread higher. The price distribution analysis also shows us that 90% of listings are priced below $300, and the common range of pricing is from $50 to $200. And we also see that less than 1% of the listings are high-end listings, which are above $100. Sorry, which are above $1,000. So here we have the correlation table, which is under the market segmentation and correlation insights. The key finding that we saw or that we got from the correlation table is that there's no multicollinearity issues detected among the predictors, which shows that the data set is suitable for modeling. Under data transformations, we cap the price at $1,000 to prevent extreme values from distorting the model estimates. We also converted room type and neighborhood to factors for compatibility with linear and tree-based models. For computation, we calculated distance using the Harvesting distance computation, and we also went ahead to handle missing data to make sure that we have the right data to give the right results. Under predictive modeling, we went ahead to put in some strategies or measures in place to avoid overfitting. What we did was we did a 70-30 train test split to evaluate out of sample performance. We also went ahead to do a 10-fold cross-validation for linear regression and decision tree, and an OOB validation for random forest. As I mentioned earlier, we also upped the price at $1,000. We also pruned the tree to select the simplest tree, and then we did a VIF analysis test, which confirmed that no serious multicollinearity existed among the predictors. So after we did the VIF analysis, that is what we found out. Under model tuning and resampling techniques, the modeling approaches we used were the linear regression model, the decision tree model, and then the random forest model. Among the three models, we chose the one with the lowest RMSE, and that was random forest. That was the random forest model. It had an RMSE of 113.19, which confirmed the best balance of accuracy and generalization. So that's why I went ahead to choose a random forest tuning. The linear regression tuning and decision tree tuning had relatively higher RMSEs. That's why I went ahead to choose the random forest decision or the random forest model. Under measuring predictor performance, this is the graph that shows the top predictors identified after we selected a random forest model. We noticed that the top predictor was the room type, followed by the reviews per month, followed by the minimum nights, and then the number of reviews, the calculated host listings count, and then the neighborhood group, and then the availability 365.
So this is our model comparison using RMSE on a test set. So we found out that linear regression has the highest RMSE, followed by decision tree, and then random forest, which has the lowest RMSE, confirming that random forest did a good job on the training and the test, and it's a good predictor for these projects. Now, going into our prescriptive analysis, we're already looking into the predictive, which help us to know price estimation. Now, the prescriptive analysis would help Airbnb host to set optimal pricing strategies so that they will be able to compete in a way of not underpricing or overpricing. So first of all, we took into consideration the anchor point, which was Midtown Manhattan, as the anchor point, and our optimal radius was 1.75 miles, which balances listing inclusion and price concentration. Also, we use the weighting function to make sure that there's a travel friction and convenience. Now, this is our sensitivity chart. Looking at our sensitivity chart, we realize that at each distance or at each radius or at each mile, there is a weighted price being assigned to it. So looking at radius of 0.25, you can see that the advice is that you should be strategic and set your price around $600. And then looking at mile 1.75, we can see that mall had the highest optimal pricing point. So that price is actually around $900 to $1,000. So this is actually helping our Airbnb host to set strategic prices based on the distances. To further prove that our optimal pricing strategy should focus the anchor on the Manhattan. So we actually use Manhattan as a benchmark because it had the highest weighted score, and then it has the highest number of listings. So we can see from our table here that Manhattan had a weighted score of 89.4, and the number of listings were 2,478, followed by Brooklyn and then Queens. Moving on, this is our integrated results and decision analysis. So we use the descriptive insights to check our market segmentation, and then we did a predictive analysis where we got Random Forest to achieve the lowest RMSE, which means that Random Forest actually did a good generalization and also did well on capturing nonlinear relationship, unlike that of the linear regression. So for the prescriptive strategy, so we are seeing that our host should take into consideration geographical factors in terms of radius, where we stand for miles in our analysis to set optimal prices. Now, for our conclusion and business recommendation, we are saying that firstly, Airbnb should strengthen value segment pricing. So they should focus on $80 to $25 range with dynamic pricing and value choice labels. We're also saying that Airbnb should separate luxury niche. Our third point is that Airbnb should leverage demand signals. So we are saying that Airbnb should integrate machine learning into smart pricing with behavior-driven alerts and what-if simulations instead of depending on intuition. Now, our final recommendation is that Airbnb should use geographic pricing zones, which the prescriptive analysis further confirmed this for us. So this will actually help guide hosts using location-based anchors and broad-level insight to set a good strategic price that will help them to compete in the market. Thank you.
Thank you.
Thank you very much.